All right, so we are getting into trigonometry. So you guys have done a bit of trigonometry in the past, and you're probably getting tired of even seeing this one, but you've done this before, right? This should all look familiar. A squared plus B squared is equal to C squared, right? You guys have seen that one before. So I want to go over just first, just a bit about the way that we label triangles, right? So you've seen this before, right? Where we had A, B, and C, right? So that's standard. But the one that you maybe haven't seen so much is that we use a capital B for an angle and like the capital letter for all of our angles on those ones. And what the pattern that's going on there is that B, so if this is side B, then angle B would be directly across from it, right? So angle B on that side, angle C would be across from little c, and angle A would be across from little a, right? So that's how those things are labeled. Okay. And now the new part that you guys haven't actually probably seen at all is we can label these things a little different too. So what the idea here is that up until now, what we did is we said, okay, if we knew the length of this side and we knew the length of this side, we can use those two things to figure out what that side length was, right? The new part of this is that we're going to start throwing in angles into it. So what we can do now is like we can do things like saying, okay, if I know this length and I know this length, then I can also figure out the angle, right? So we're kind of throwing angles into these right angle triangles now too. So in order to do that properly, we come up with some new names. So the opposite side, one sec. So the opposite side is always going to be on the opposite side of whatever the angle was. So if I'm looking at angle A, then the opposite would be on the opposite side of it. The adjacent side is always going to be, well, adjacent to it. And the word adjacent means beside. So it's going to be beside the angle that we're looking at. Now, I just want you to be careful in that because this would change, right? Where if I was looking at a triangle, let's say it was the same triangle, right? Let's say it was like that. But now if I was looking at this as the angle, well, then what would happen here is that would make this the opposite side and this the adjacent side. And then the hypotenuse is still the hypotenuse. That one's always the same. But these two will switch depending on which angle you're looking at. So if I'm looking at this one, they'd be that way. If I was looking at this angle, they'd be that way. Okay, so just careful on that when you're labeling these. So now what the idea is that a lot of smart Greeks figured out, well, some patterns. They figured out the famous Pythagorean equation, right, for side lengths. But they also noticed that the ratios of the side lengths were always the same for the same angle on a triangle. And what I mean by that is, well, here, let's look at these triangles down here. So if I look at, these three triangles, they all have the same angle there. Even though they're different size triangles, they all have the same angle. And what these smart Greeks figured out was that if I, let's say for this first one, opposite over adjacent, they figured that this length, the opposite side, divided by the adjacent side, would always give you the same ratio. So it would give me 0.67 for this triangle. And if I did the same here, if I went this number, the opposite, divided by the adjacent, right? Opposite divided by adjacent, I get the same number, right? It's the same ratio. And same with this one. This one divided by this one gives me that same ratio, right? So they were able to use that. And same thing. So that was opposite over adjacent gave you that. But something similar, opposite, so that side over the hypotenuse, so over that one, would give you that number. And it would also be true for the middle triangle and then the smaller triangle. And then the same thing with adjacent over hypotenuse. So this one divided by this one would give you the same number for all three as well. Okay, so they were able to start putting that to use. They gave these things special names. They gave them the names. So opposite over hypotenuse is called sine. Adjacent over hypotenuse is cosine. And opposite over adjacent is tangent. Okay, this is going to come up a lot and for the rest of your high school math and physics. So An easy way to remember this, so these things here, you can remember, you probably heard this like other kids using this, is something called Sohcahtoa. And you can write it out like this, but I kind of like to write it like this a lot of times, where it's S and then O over H. So Sohcahtoa. And it's just an easy way to remember these things up top, right? That sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay? And I'll get to the gist here, like what we're talking about here in a minute. But first off, let's just talk about just one of these. We're going to talk about the TOA part of it. We'll talk about the tan ratio. Okay, so the tan ratio is that, okay, so if I'm looking at this angle, then the opposite side is down here, right? So what the tan ratio is the opposite length divided by the adjacent length, okay? That can be written different ways. Sometimes you'll see it like this, where it's tan of A, right? So angle A. So that's what you'd write. You write tan of A, because this is angle A, is equal to, and then it can be equal to any of these things, right? It can be equal to any of those. Yeah, so written out that way, or that way, okay? So now looking at this a bit closer. Okay, anyway. There we go. Okay, so if we were looking at, let's say, this one here, right? Then that would just be the tan ratio. So I'd say tan of angle, in this case, F, is going to be equal to the opposite over adjacent, right? That's the TOA part of it. So that'd be 3.5 over 2.2. Okay. And then to find the angle, so for G, sorry, then G would just be the other way around, right? Because now we're looking at this angle, G. So now the opposite would be the other way around. It'd be 2.2 divided by 3.5 to get that ratio, okay? So now, why is that useful, right? Well, why that's useful is that we can actually calculate the angle based on these ratios. And what the Greeks did a long time ago is they would actually measure out different triangles and they divide them. They meticulously measure out, okay, 2.2 divided by 3.5, and they get really accurate with it. And then they'd use a protractor and actually measure out what the angle was. And doing that, they were able to make a table. So they'd say, okay, if the tangent ratio was this, well, that would be the same thing as 10 degrees. If the ratio was this, it was 20 degrees. And they'd give you a table that you just look at, and then you'd know what the angle was based on that. We, on the other hand, have calculators, so we can do that this way. So you guys will see on your calculators, you'll have buttons called sine, cos, and tan on your calculators. That handles this. We don't have to do that anymore, okay? So what we do now is if we had something like this, and I'm gonna write this out a different way for a second. If we had tan, well, here, I'll do one of these questions. Let's say we had a question like that one there, right? So we'd say tan of F is equal to 1.591. All right, if you guys have a calculator right now, that'd be fantastic. If not, just maybe really pay attention. But the way you would do this is that if I'm doing tan of angle F and that's equal to this, well, what I need to do is I need to like untan it. It's kind of like, it's like doing the inverse operation. So it's kind of like when you're multiplying something, you can unmultiply it by dividing, right? You can do the inverse operation. So the inverse operation of going tan of F actually looks like this. If I want to figure out what just the angle F is, I could say the angle F is equal to, and then it's written like this. I know this will be new to you. And it's tan -1 of 1.591. Right? And that -1, what that means is the inverse. We'll start using that more in like 20 level math and 30 level math with that inverse function. But that's like undoing it. It's like doing the opposite of tan. So can you guys right now, if you have your calculator with you, this is what you do is you go, well, you'll see if you look close on your calculator there, you should have right above tan, it'll say tan -1. And the way you get that button is by pressing the second function and then that tan button, right? And that should come up as tan -1, and then just type in that. Now, that might give you an error. It might tell you that you have a problem there, right? So, you know what? I was going to bring up my calculator on my computer, but I think that'll make everything slow right down. So I don't think I will. If that tells you something funny that doesn't look like an angle, like if you ended up getting a number like, 0.3 or something, which doesn't really look like an angle, what the issue is going to be there is that your calculator is in radians and not in degree. So what you're going to want to do on your calculator, you're going to go into, here, one sec. I just want to double check before I tell you the wrong thing. Into mode, right? So you're going to press mode on this kind of a calculator. And then if you go down like, 3 of them, you'll see that there's degree or radian. And that's on the TI 83 and 84. Now the TI Inspire, you're going to go to your home screen, and then it's under document settings. And then you got to go into there and then change it into degrees, right? Because that's everything we're doing is in degrees. So you might already, like if you do this calculation and you get 57.8 degrees, then you're good to go, right? But if you get like a weird number, like a decimal, then you're in radians and you gotta change that in your calculator. Okay, so if you're having trouble with that, maybe stay in after and you can like show me your screen, or we can work on figuring that out. Okay. All right, so this one. For the given triangle, determine tan x and tan z. All right, so tan x. So here's what we're going to do. We're going to say, okay, this is the angle we're looking at. So a good way to do this to begin with is to label them to begin with, just so we don't get confused. So if I'm looking at this one, then the opposite side is that one, right? That's the opposite, which would make the one beside it, right, the adjacent. And then the longest side is always the hypotenuse, right? And hopefully you guys are a little better at the hypotenuse, because that's always been the hypotenuse. You guys have been dealing with that since grade 7, I think. So that's the hypotenuse. Oh, hypotenuse. So now, typically the way you'd want to set this up, we know what it is, but you'd write out Sohcahtoa. And then I'd say, okay, well, they've given me the opposite and the adjacent, and I'd say, okay, well, I need tan, right? So we'd write, okay, so then you'd write it out. The tan of angle X is equal to, and then that's where this comes in. You're going to write it in as opposite over adjacent. So the opposite here is 6, and then the adjacent is 12. Okay, and then the next step is you'd write in, well, this is what tan of the angle is. Tan of the angle is 6 over 12, which would be the same thing as 1 over 2 or 0.5. It doesn't actually matter how you write it. I don't want tan of the angle. I want the angle itself. So my next step is to go x is equal to tan negative 1 of a half, or 0.5. Okay. So if you put that in, you should get tan negative 1.5. You should get x is equal to 26.6 degrees, which you could round to 27 degrees. Okay, so that'd be x. And now, oh, sorry, I did 2 parts here. So part A said just determine tan of x. Okay, well, tan of x was a half. And then the angle was 27 degrees. So that was part A, and that was part B. Now, if we did for z, we'd go tan of z is equal to, yeah, the other way around now, right? Because now, if I'm looking at z as my angle, what changes here is now this is the opposite side, right? That's on the opposite side of the angle. So that's the opposite, and this is the adjacent. So that will change things up, right? It's opposite over adjacent. So this is now going to be 12 over 6, right? Opposite over adjacent. So that would be the same thing as saying, okay, tan z is equal to 2. Okay, so that would be tan of the angle, right? That's the ratio. And now if I actually want the angle itself, that would be z is equal to tan -1 of 2. So tan -1 of 2 is 63.4 degrees. So I'll just round that to 63 degrees. Now, that makes sense, right? Because actually all of my angles, so that'd be 90 degrees, 90 plus 27 plus 63, that's giving me 180 degrees. So that looks like it's right. Okay. So that's the idea. That's really the skill. If you guys can do that, we're good to go. Because now what we're going to do is we're going to do the sine and cosine ratios, but they're really the same thing. So in this case, we're looking for angle K. Well, according to Sohcahtoa, then I'd look at this and say, okay, well, here's the opposite, and there's my hypotenuse, and I'd look at my Sohcahtoa and say, okay, well, this one has opposite over hypotenuse. So I'd say, okay, sine of K is equal to, and then just make sure we were in the right order, 4 over 4.3. And if you do the same thing we did before, right, then you'd end up with 68.5 degrees. Okay. I'll do, yeah, we'll do this one too. Oh, and then, yeah, sorry, I never did do it like a cos one, but it'd be the same thing. So now in this, yeah, this will be one where it says for angle Q. So we'll again look at Sohcahtoa. And we'll say, we'll try to label this. So I'm looking at this angle, which would make this my adjacent side and this my hypotenuse. I look up here and say, which of these deals with adjacent and hypotenuse? Well, this one does, right? Adjacent over hypotenuse. So that's cos. So I'm going to write it out as cosine of Q is equal to, and then adjacent over hypotenuse, so that would be 4 over 5. So then Q is equal to cos -1 of 4 over 5. So in your calculator, we can go cos -1 of 4 divided by 5, and we get angle Q is equal to 37 degrees. Okay, number 4 says calculate sine 30, cos 30, and tan 30. Okay, so now when it says calculate sine 30, right, just imagine what you're looking for here. What kind of answer am I even thinking I'm going to get? I'm going to get a ratio, right? Sine of 30 is saying what is the ratio when the angle is 30 degrees? That's really saying if I had 30 degrees, right? What is the ratio? What is this side divided by this side, right? Opposite over hypotenuse. That's what it's saying. So that what I'm looking like, what this will be some kind of decimal is what I'm after. So we'll see if that makes sense. So if you just type in, this time we're not going to go sine -1. You're actually just going to write it in just like this in your calculator. You're going to hit sine 30, and then 30. No, sorry, sine 30 is 0.5. Now, you guys on a TI Inspire, you guys have a button on the left side of your calculator that says trig. If you click that, you're going to get sine, cos, and tan, and all those things right in there too. So, okay, and then cos 30, doing the same thing. Cos 30 is 0.887. Actually, it's not degrees. It's just this is a ratio, so just 0.87. And then tan 30. Sorry, my pen's kind of out of calibration here. Tan 30 is equal to 0.58. Okay, that's it. So you guys do have a few questions here. They're pretty quick though. You can kind of see like a lot of them just kind of go, yeah, like these once you get into it. Just to make sure you guys are on the right track here, it says in each triangle, write the tangent ratio for each acute angle. So acute angle is not just a good looking angle. It's a small angle. So less than 90 degrees, right? So each acute angle would be that angle and that angle. Those are both acute angles. So in order to do that, you're gonna have 2 for every one. So for this question, you'd have the tan ratio of A and the tan ratio of C. And that's really just using both those numbers, right? So look up above to kind of see that one. To the nearest degree, determine the measure of angle X. And yeah, so you should be good there, just doing what we did. And then, yeah, they get a little bit more difficult as they go on, but it's all the same idea. So yeah,